Hey everyone, thank you for joining us today for VMware's multi-cloud live stream. Just a reminder to everyone listening that these are demos taking place every week on Tuesdays and Thursdays, and we're featuring new speakers and topics. The recordings are also hosted on VMware Cloud on our YouTube channel, so you can watch those on demand and see what's coming up next. So we encourage you to subscribe to that channel so you can stay up to date with the latest. Today, we're excited to have Ron here with David and me today for our session on ensuring network security. So this month, we are focusing on all security-related sessions. So this one is dedicated to network security. So Ron, if you can just give a brief introduction to yourself and then an overview of what you'll be demonstrating today.
Certainly. My name is Ron Fuller. I am a senior technical product manager in VMware. I focus on networking and security inside of VMware Cloud on AWS. Today, we're going to be talking about the NSX Advanced Firewall for VMC. That is a new capability that we just recently launched that allows customers to be able to do things like intrusion prevention and detection, as well as layer 7 firewalling, identity firewall, and FQDN filtering. We're going to be focusing today primarily on the IDS IPS aspect of it, and I think we've got a pretty exciting demonstration lined up for you.
Happy to have you here. Thank you.
Yeah, I'm really looking forward to it, Ron.
Yeah, thanks for having me. So let's dive right in, right? So from a super high level perspective, inside of VMware Cloud and AWS, we already provide two security mechanisms for customers. We have what we call the edge firewall, which sits at the perimeter of the software-defined data center that provides north-south firewalling from anything that comes into or leaves the software-defined data center. Additionally, we have the distributed firewall, which sits inside the software-defined data center that allows us to be able to protect workloads from an east-west perspective. This allows customers to do things like microsegmentation of their infrastructure and enhance the overall security posture of the environment, which is obviously a very important consideration, especially when you start talking about that move to cloud or migrating workloads to a cloud-based infrastructure. What we're doing with the NSX Advanced Firewall for VMware Cloud and AWS is we're enhancing those capabilities. We're adding a full layer 7 distributed firewall that allows us to be able to do deeper packet inspection and see what's happening inside of a HTTP or HTTPS stream and make sure that it's a legitimate protocol or solution that you want to have go through your firewall. We also support distributed fully qualified domain name filtering, which allows us to be able to filter traffic based on the domain name that's being used. And that's important, especially when we start talking about software as a solution type of environments. We have the identity firewall that integrates into Windows Active Directory and allows us to be able to define security policy based on user login name and group membership, which is particularly powerful for end user computing environments. And then the focus of today's session is definitely the distributed IDS IPS and how that layers into the infrastructure to provide a really comprehensive threat detection infrastructure that allows us to be able to really enhance the overall security posture of our customer workloads. So when we look at how this distributed IDS IPS is built, it's built on the same mechanism that we use for the distributed firewall, which we've had for some time, right? From a VMware perspective, it scales horizontally across all of the hosts in the infrastructure and reduces the need to have a virtual appliance or if you have physical appliances in the physical world that do IDS IPS traffic. It also, from my perspective, being a network engineer, really simplifies the configuration to be able to minimize the requirement to have what I would call networking gymnastics. The customers have had to do in the past to route traffic through these appliances and get them through the environment. Because it is instantiated and configured on the virtual NIC of the guest machines, all traffic entering or leaving that virtual machine pass through the distributed IDS IPS filter. So it enhances the overall security posture, moves it very close to the workload, and also scales out horizontally because we're leveraging this functionality on every single host in the software-defined data center, as opposed to a big appliance or a virtual machine in the sky, right? So it definitely helps from that perspective. We also utilize a very curated signature distribution methodology that allows us to be able to be selective about the signatures we implement in the solution, that results in fewer false positives, and equally important, lower overhead on the host, right? So in a software-defined network infrastructure, everything that you do has a CPU and or memory cost associated with it. So the more we can do to be conservative with that and reduce that overhead is important. Allows us to also have context-based threat detection that allows us to be able to be more proactive in how we do alert prioritizations and helping our security operations center folks understand what they're receiving from an alert. Am I receiving, a significant alert, a critical alert, a high alert, right? And being able to provide some of that detail. And then also a unique attribute of this is that it does associate itself to the state of the virtual machine, which means that now that policy and the IPS state follows that workload as it vMotions around the software-defined data center, right? So it follows the workload wherever it goes. So very cool stuff. When we look at it from a demonstration perspective, this is our topology. It's very, very simple. It's a single software-defined data center with just a handful of virtual machines in it. We have an appliance that's utilized for this type of testing and demonstration purposes called DVWA. That is our victim machine that we'll be launching attacks on from the desktop. So you can see that they're all in the same IP subnet, which also for a lot of other appliances or solutions is a very challenging environment because they're all in the same subnet. I don't have a way to easily artificially route them through an appliance. So in this particular demonstration, what's going to be relevant is that they're on the same subnet. We're going to be able to prevent an attack from happening and see the associated alerts that are configured with that. So let's jump into the demo and see what we have cooking over here.
Hey, Ron, just on the architecture you were showing there, it seems like that was an important point. This idea that because it's happening at that host layer and sort of it can see things that if you had something that was sort of more external to that you wouldn't be able to protect against. Is that fair? Because I think the point I picked up there was that
absolutely.
This architecture allows you to do things that you just wouldn't be able to do if you did it some other way, basically.
That's exactly it, right? So this definitely enhances our customers' security posture because we're able to protect that east-west traffic, which is traditionally a very difficult point to protect because of the way networks work, right? So by being able to have this service on the virtual NIC of the guest really gets us as close to the workloads we possibly can without being inside of the operating system in that Goldilocks zone, right? We've been talking about Goldilocks zones for quite some time from an NSX perspective. This builds on that same principle and just brings additional feature functionality for our customers to enhance their security. So pretty cool stuff.
Yep.
Absolutely. So here we've got an environment where we've got our demonstration SCDC, and the kind of journey to configuring this starts by enabling the add-on, right? So it's already enabled because we're doing a demonstration. We don't want to go through all of the actions, but know that the only difference you would see in your environment would be that this says activate versus deactivate. Click on activate, and that enables the ability to configure some new tabs that are present in the UI. So over here on the right-hand side, left-hand side, we can see we've got a new selection for distributed IDS IPS that we can configure. And inside of here, we've got a number of different screens we can review. So we'll kind of start moving from right to left just so we can kind of build the progression of how these things are configured. But our settings tab is where we start to configure things like the signatures, and we can have multiple versions of signatures that are automatically downloaded from the NSX Threat Intelligence Cloud services, right? So it helps customers maintain a security posture by having the most current signatures applied. Certainly, there's options to be able to not have it automatically updated, and you can run a known quantity of signatures if that's your company's perspective. We also have the ability to be able to upload IDS signatures if you don't have connectivity. Maybe it's an air-gapped environment. A lot of our government customers have this type of requirement to say, hey, I can't plug my workloads into the global internet because, well, it's the global internet, right? There's a lot of weird people out there, and I have to have an air gap. They still can take advantage of this feature by doing a manual upload.
Sorry, Ron, just the idea of signatures. Can you elaborate? I mean, I kind of I think I know what it was, what you mean, but not everybody's an expert. And signatures are effectively what, basically?
They are fingerprints of various attack vectors, right?
Mhm.
So there's any kind of a particular attack has a list of attributes that are associated with it that makes it recognizable.
Okay.
And so those are what are compiled into the signatures, and that's what the IDS actually scans for. So when it looks at the packets, it says, hey, I'm matching it against this known list of attributes of bad behavior.
Yeah.
And then those are all classified based on severity and criticality and products and things of that nature. So it's really like a big database
Yeah.
of known attacks, but it's very compressed and small so that it's not chewing up a ton of memory, it's not chewing up a ton of resources, right?
Yeah, I always think of signatures like fingerprints, right? It's like
Yeah,
you can
absolutely.
identify what it is, basically.
That's exactly it. Yep. And so like in this particular signature set, we've got 15,000 signatures, right? So 15,076 attacks we can prevent against. So that's pretty good. So we can enable it on a per cluster basis. And depending on your data center design, this might be multiple different clusters. Obviously for a demo environment, I only have the one, so it's enabled by default, right, for my cluster. We can also define profiles. And these profiles are actually a very powerful configuration option because I can be super granular in here as to what kind of signatures I want to monitor for. So I can, in this environment, I can say, hey, I only really care about high and critical signatures. But if I've got a requirement from my security admins to say, you know, I need to only monitor for items that have a certain CVSS score, I can go in and further refine it. So I can become very surgical in how I apply this policy for those types of signatures or fingerprints, like we talked about just a moment ago, that I want to monitor for. And so I can say, hey, I only care about high criticality CVSS events, and I can further refine that filter of signatures down to be specific to what I'm looking for. I can also do things like product selection. So I can say, hey, I'm not running Windows in this environment, so I don't need to worry about looking for Windows fingerprints or signatures, but maybe I'm running Apache. And I can go in here and say, oh, hey, I'm running an Apache Tomcat server in this environment. Let me just focus on, again, being very surgical on just the Apache Tomcat type of vulnerabilities. So it gives me a ton of flexibility to be able to really construct a profile that meets my specific requirements, makes my security infrastructure much more focused and tactically hardened against those types of environments. Obviously, for a demo environment, though, we've got it kind of pretty open at both critical and high. So now that we've defined our profile, the next thing where the rubber really hits the road for us is we need to define a policy. And this is the same policy engine that we use inside the distributed firewall that allows us to be able to configure multiple different attributes, right? So I've created a policy called corporate policy. I'm not very creative with my naming. And then I've created a rule called secure app. And I'm telling it the sources are local prefixes. So for me, that's a group that I've manually defined inside of my software-defined data center that says any of the subnets that I create are subject to this particular policy. And then the traffic is to any destination on any service. And there's my IDS profile. So that's where I get that granularity. I can say, I want to look for just critical and high alerts that match this particular criteria. And then equally important, I want to do detect and prevent. So this is the detect part is obviously the intrusion detection services. The prevent part of it is the IPS, which means that we will actively stop an attack if we see it matching that particular signature. So in this environment, I want to have a very hardened infrastructure. I want to prevent attacks before they even happen. So that's what I'm going to do. And our last pane before we actually get to the cool part of the demo where we launch some attacks is here where I've got all of the previous attacks that have happened over the last period of time. So we can see that last night some attacks happened when I was doing this demonstration for some colleagues in Asia, but right now there's nothing current, right? So we can see the timestamp 9:53 p.m. It's 1:25 p.m. my time. So we'll see that change as we go through the demonstration. So we mentioned that in the demonstration topology, we've got a desktop that we're going to use to be the attacker against the DVWA appliance. So our first thing we're going to do is we're going to launch a scan, right? And this is something that a traditional attacker might do to try to get an OS fingerprint, understand what ports are open on the machine, understand what applications might be running on the machine. Is this running SQL? Is it running Apache? Is it running a web server? You know, what are my potential attack vectors? I'm going to start by doing this kind of scan. So while this runs in the background, we're going to go ahead and log into DVWA, which is an appliance really designed to help companies test their security infrastructure. So we've got the DVWA appliance. We're going to do a SQL injection attack. So we're going to try to do a union select SQL attack, which just says, hey, I'm going to go in and I'm going to try to overrun the database and make it do abnormal things and potentially create an error condition that allows me to get in and do bad things, right? Because I'm a bad guy at this moment. So we're going to go ahead and tell it to run. And the behavior that we're going to see is that normally this just goes back to the screen and says, hey, the attack was successful. But we can see that it's just sitting here spinning, right? It's timing out. It's not doing anything. Additionally, our Zen map went through, and what we'll see is that it wasn't able to identify as much of the environment as we would like it to, right? So it did do some identification just based on the fact that port 22 is open for SSH and port 80 for web traffic, but it's not able to identify all of the details that it normally would during an OS fingerprint. So let's go back over here to our console. We'll do a quick refresh, and we'll see that we now have some current state attacks, right? So look at the timestamps, August 12th, that's today at 1:27 p.m. And we can see that we now have some attacks that have happened, and we have prevented them, which is equally important, right? So we can see the client VM talking to the server, and we see a lot of different attributes associated with the attack. And we can roll through this and look at the specific signature that was triggered and get a lot of detail on this. And then take a corrective action if needed, right? Let's try to track down the source of the attack, and is that somebody internally doing something that they shouldn't be doing, or is that an external attacker, and we just need to be aware that somebody was trying to rattle the doors and get into our environment. We can see that some happened last night, and then obviously prevented again today. So very quickly we can configure some policy that protects our environment and have it be proactive in preventing these kinds of attacks from happening without a whole lot of work, right? We didn't have to do a ton of configuration to make this happen. You saw the steps that I've had to follow through the profiles and the rules to define that policy. It's very, very straightforward. And because of it, now we have a more secured infrastructure. So that's kind of IDS IPS in a very kind of quick overview. Certainly there's a VMworld session we're doing that's a full hour kind of super deep dive in this. So if this is something that's interesting for the viewers, feel free to sign up for the VMworld session, and I will bore you to tears with detail on how this works and what it looks like, right? So there's a lot of good information to share. We just kind of scratched the surface, but hopefully you got a quick feel for and flavor for how this works and what it can do for you. Yeah,
it's awesome. And you said this just became available on VMC on AWS, right? VMware Cloud on AWS.
That's correct. Yes. Yeah. That this was part of our 1.15 feature launch. So.
Right, and it's been available on vSphere in the data center and all that for some time. Right, I think
that's correct. Yeah.
We just hadn't been certified and sort of fully brought to market on VMC on AWS, VMware Cloud on AWS.
Exactly.
So,
exactly.
Perfect. It's really, it's great. I really love the capabilities that we've brought to market with NSX. They make so much sense. I had a bit of a background with some of the networking security in the past, and this was even before a lot of this, before NSX hit the market. So it's like, I know what a nightmare it can be to try to manage firewalls.
Definitely.
One question that I had was, so with those prevention, it's either detecting and preventing, either or, that you can specify. Will you be able to, without going into the platform, receive an alert, perhaps via email or something, to let you know that the detection or prevention has taken place?
Yeah, absolutely, and that's an important aspect that we didn't really get to touch on here, but certainly all of those events get sent to what's called Log Insight Cloud. So all of our VMC customers automatically get Log Insight Cloud as part of the offering that we have. And once inside of Log Insight Cloud, they can configure the Log Insight instance to take different actions. If I see this type of alert come through, I send it to an email group or to an on-duty pager, or who knows, right? Some sort of SMS group, so that a lot of people get notified that, hey, bad things are happening right now. Somebody needs to log in and check out and see what's happening. So absolutely, you can distribute that information and disseminate it so that you can take action, because obviously security is never happens in the middle of the day. It always happens, when we're asleep, and somebody's got to wake up to take advantage of it.
Right. Absolutely. Makes sense. Thank you so much for that overview. Yeah.
I'm sorry. We got a question, Ron, there. I'm just showing it on this. I don't know if you can see it, but it's understand how to migrate on-prem IDS, IPS to NSX. Is there a tool or something? I don't know if you can comment on that.
So right now they are kind of configured and maintained as separate islands, right? So whatever I configure in my on-premises world stays on-prem, and I would have to configure a similar or consistent policy in the cloud-based world. We are looking at solutions that will come to market, soon. We don't have NDAs in this session, so we can't get into a whole lot of detail. But certainly, solutions that are coming to market that will help with that policy consistency and coherency between the on-prem world and the cloud world. So,
okay, cool.
Yep.
Thank you so much for that. It's good stuff. I love it. I'm just happy to see more and more of the NSX capabilities find their way into the public cloud, as well as VMware Cloud on X, if you will, right? So I think it's awesome. Yep. I think it's great.
Yeah. Well, thank you. Thanks for having me on. Hopefully this was helpful and useful, and I appreciate it.
Thank you. Yeah, everyone, thanks so much for joining us if you were able to join live. And for those who aren't able to, you can, as a reminder, check this out on demand on our YouTube live stream playlist. So you can check out this session on demand, as well as all of the previous ones that we've held. And as a final note, please feel free to subscribe to that channel. We would love to have you so you can get notifications when these are coming up, and see what other sessions we have around security for the rest of this month. So we're hosting them Tuesdays and Thursdays at 10 a.m. Pacific.
And as Ron mentioned, VMworld's coming in October. So, book your seat. No, it's virtual, so you don't it's easy to book your seat. But it's going to be great. I don't know. I think we've got hundreds, if not thousands, of video sessions, but a great set of keynotes and everything too. So, and it's a great place to learn more about NSX. There's going to be a ton of content around NSX, as well as VMware Cloud. So be sure to check that out as well.
Absolutely. Thanks again, Ron, and maybe we'll see you on here another time.
Yeah, we're happy to have you back. It was a great demo, and there's this. We only scratched the surface of some of NSX capabilities. So,
absolutely.
I think we can definitely dig in more there as well.
More than happy to.
All right. Thanks, everyone, and we'll hope to see you next time.
Thank you.
Thanks.
Bye.
Bye-bye.